Good day and welcome back to Best Practices for 3D Modeling. For the second video we're going to take a look at placed features. Placed features are located in the refinements. As we have seen in the last video, we were talking about sketch features. Placed features are similar to sketched features, however they do not require an initiating sketch. The classic example of a placed feature would be a hole. However, other types of placed features that we can also create in the refinements of a 3D model will include also fillets, chamfers, the ability to shell or create what are known as thin-walled objects. So let us take a look at how a placed feature ranks within the refinement of a 3D model. Here we are back in Inventor. Here is the plate that we were looking at previously with sketched features. We're now going to use the same plate to initiate and place placed features. Placed features, as I said before, consists of holes, fillets, chamfers, shells. We can also create different types of placed features such as drafts and also threads. We're going to concentrate on the primary placed features, in this case the holes and the fillets, and also we will take a look at shell. So we'll start with fillets. A fillet is a rounded corner. So when I click on fillet, the dialog box pops up and I am able to add fillets. The fillets themselves can simply be, when we click on an edge, we're able to apply a fillet. We can indicate what the size of the fillet is. For example, if I want it to be 5, as I type in 5, the fillet itself adjusts. However, we can also click on the little yellow arrow, and holding down the left mouse button, we can do a what-if scenario, such as testing out to see how large or how small we would like the fillets. As we do that, the radius callout automatically adjusts to indicate what the size of the fillet is at that point. Here we've specified 2 edges. We can also indicate other fillet sizes by clicking in the dialog box where it says click to add, and then selecting different edges. So for example, if I wanted to select this edge and this edge, and I wanted to change this to say 3, these act independently of the other fillets. I can continually add more and more rows of different fillets. For example, if I wanted to click another row, and in this case I want to select the top edges all around, and then I will indicate that to be 2. So by doing this, we actually have a group of 3 different fillets, starting from the corner edges. I'll make an adjustment, I'll make that say 14. We have the opposite end, which is 3 millimeters, and then we have the top end, the top portion, which is also 2 millimeters. I'm going to also add this edge to finish it off and cap it, and then click OK, and now I have my fillets. Okay. As always, if I wanted to make a modification, for example, if the 14 is a little too deep, I need to make a change to that. Because this is completely grouped, I can go into the single fillet, go right mouse button, edit feature, and then select the fillet that I want. In this case, it just happens to be the first one. I'm going to select the radii, and in this case I actually want it to be 10 as opposed to 14, so I can type in 10 and then click OK to apply. Alright, I'm going to delete these fillets. If I wanted to create a group of fillets where I can single each one out as opposed to going into a single fillet grouping, I can individually create a fillet by going fillet. Once again, I'll take 14, I will select these two. Now rather than clicking OK, I'm just going to click apply, and that applies that fillet, but maintains the dialog box so I can add another set of fillets. So I'm going to select these two, and I've indicated that this I actually want to be 3. I'm going to apply those ones, and then the last one I'm going to select the entire edge, and then indicate that to be 1.5. And in this case, that is the last operation for the fillet that I need. I'm going to click OK. So as we can see right here, 3 different fillets have been made, making it a little easier to isolate the fillet that I want. Okay. I'm going to eliminate this fillet, so I'm going to just right mouse button delete it, because I'm going to end up using the curved sides to demonstrate my hole command. So the hole command, which is located right here, the dialog box as this pops in, comes into view. We have the following. We have the types of holes, which consists of simple holes, we have clearance holes, we have tapped holes, and we have tapped tapers, which are NPT type holes. The seats themselves, we have simply no seats, which is basically a through hole. We have a counter bore, we have a spot face, and we also have a counter sink. The behaviors, termination, so we can indicate the depth, we can say it to go all the way through, or we can also indicate to go to a certain set point. And we're also able to change the directions. On the advanced properties, which is right here, let's open it up. What we have here is 2 primary advanced settings, one which is iMates, which will become very useful when it comes to assemblies. It creates half of a mating pair. However, in the parts creation, this is probably more useful. This is the extended start. The extended start is if we create a hole on a curved surface and we actually are creating that hole below the curved surface, the extended start will allow us to punch through that surface without having to create a separate sketch. We're going to keep it fairly basic for the time being, and in upcoming videos we will also take a look at more advanced uses of the hole command. So let's take a look at the simple hole. The simple hole, we can select the surface that we're going to create the hole in. So there's the surface. Now we want to match that hole to, say, to be concentric with this cylindrical surface of the fillet. So if I click on the surface of the fillet, what it does is that it finds the center. Now the hole as well as the fillet are concentric. I can grab the gold ring and then just drag it out to increase or decrease the size of the hole. And also the arrow, which is shown right here, I can indicate how far I want it to actually drill through. So if I want it to drill through only to about 2.5 millimeters, we know that the plate is 5 millimeters. It is going to drill through to 2.5. However, as you can see, it also will poke through the opposite side of the plate. This is due to the fact that the drill point is being used. If we only want the hole to be a flat bottom, we also have the ability to change the drill point. Here is the options in the dialog box. If I click on the flat, what it does is that it gives us a flat mill style drill point, and then when we click OK, we actually have that size. Holes can also be created. Holes are unique because they can be created with or without a sketch. I can select that surface and then say sketch, and then using my project geometry I can select, say, this edge to bring up the center of that fillet. When I finish my sketch and then I click on hole, I can actually take and then select that center point, and it will create the hole. In this case it is way too big, so we'll just reduce it in size. And because it's attached to the center of the fillet, it is automatically concentric with the fillet edge itself. I can indicate, in this case, how big that hole is going to be. So I'll make it, say, 3 millimeters. And then once again, I will, in this case, say OK, and it drills the hole all the way through the plate. Another aspect of holes is that we can use edges to indicate where to position the holes. So if I select, say, the surface again, it's creating the hole, but what I'm going to do is I'm going to select that edge, and it will allow me then to position it horizontally, maybe 12, and then I'm going to select this edge, and it will allow me to position it vertically, and let's make that, say, 15. When I click OK, it will position that hole according to the 2 dimensions off of the 2 edges. We can also dimension it off of internal features in order to facilitate positioning the hole in a much more logical sense. Continuing on with holes, holes also have purposes when we are creating parts which will have clearance holes. So for example, if I wanted to create a clearance hole that will be positioned at this corner, so I'm going to select that surface to position it concentric. However, this will be a clearance hole, so I will select the hole type. As I do that, it allows me then to match it up with the correct standard and also the correct fastener type. This is a millimeters drawing, so I'm going to take ISO. So I will select ISO as my standard. The type of fastener, the fastener itself we'll use as a hex head cap screw. We will indicate that this is a M4 size. And then last but not least, the fit. So the fit will allow us to give the inherent tolerance. All of the tolerances are actually coming from the machinist's handbook, which is embedded within the program itself. So we have the ability to go as a normal tolerance, a close fit, and also a loose fit. Okay. As we change the fits, the accompanying size for the clearance then becomes input. If we want to simply add our own clearance, we can simply go down and then select the value and indicate that we actually want that to be 4.2. So 4.2 will be our clearance. When we click OK, we now have our clearance hole. Let's do another one. This time what we want is we want a clearance, but it will be a counter bore. So we want a clearance with a counter bore. We will indicate that this is a cap screw. It is an M4. It's a normal fit. And this indicates what the size of the pocket for the counter bore will be. Each one of these, as always, we can select and we can manually adjust as required. For example, if I only want that to be 10 millimeters and the depth I only want to be 3 millimeters, I can then click OK, and now I have my counter bore. Okay. One more thing that I'm going to do with holes is show the ability to add threads. So if I select, in this case I don't want a counter bore, I'm going to have it as a tapped hole, and it has no seating. So the tapped hole, I will end up indicating what the size is. First of all, I will change to the correct standard and type. In this case it's an isometric profile. I will have it as a 4.5, or actually we will rationalize it to a 5mm tap. It's designated as a 5mm by 0.8mm pitch. That will be our coarse. We can also go to our fine. And also the classification. So we can go to the 6H primarily for the 8mm. For the 5mm, we have the same. Okay. Direction. So left-handed, right-handed can also be indicated, and also full depth. So if we want to be tapping to be completely full depth, we can add that. If not, we keep the check mark off, and then we can indicate on the diagram for the preview how deep the tap will be. In our case, because this hole is going through and the threading is past 10mm, it will tap through the entire. Let's take a look. Let's click OK, and now we have our tapping. Okay. As always, all of these features are editable by simply going into the history tree and editing the actual feature. We're going to take this feature and then adjust it. So we're going to go into hole number 1, go right mouse button in the history tree. We're going to go edit feature, and then we're going to indicate that the actual size in this particular instance is only a 12mm. It will adjust. We're going to click OK. Now we made that adjustment. So we can do that adjustment to every single other feature on this particular plate. Okay. I'm going to delete all of these holes. Delete. And then I'm going to also demonstrate the chamfer. Chamfer is similar to fillet. The only difference is that the chamfer provides a straight cut edge. We have 3 styles of chamfers. We have distance, which is equal. Each distance is equal, which means it is a 45 or a normal chamfer. We have the ability to indicate a distance as well as an angle, and we're also able to indicate 2 distances. We'll take a quick little example of each. So distance, 45 degrees. If I select, it produces, in this case, a chamfer of 2mm all around. Okay. I'm going to delete the chamfer, and this time I'm going to take the distance as well as the angle. I will select that surface, and then I will select that edge. Now, as we take a look at the arrows, we can actually see what we're actually producing. So the yellow arrow, which is now active, as soon as it's yellow, that means it's active, allows us to change the actual depth distance of the chamfer, and you can see also it is adjusting on the dialog box. When we select the arrow itself, that allows us to change the angle itself. So in this particular instance, with that particular throw, 45 degrees, 60 degrees will not form, simply because the angle is way too steep. The maximum for this one, I believe, is 55 degrees. When we click OK or Apply, we now have our chamfer. Once again, we will delete that chamfer and we will demonstrate the last one. Here's chamfer, and this is 2 distances. This is all we require to do for this is just simply click on the edge, and then we have 2 arrows which govern what the size of the chamfer is. So in this case, the active chamfer is the horizontal, so if I drag, it will allow me to, as always, get to a point. If it passes that point, then it will not form anymore. The same thing with if I click now the vertical arrow, I can just bring it down to as far as I need it. And if I surpass that, once again, it will fail. The reason for that is that there is no material that it can actually manage to remove at this point. So let's take it for this. So once again, we can highlight each one and also manually type in the values. Let's click OK, and now we have that. So there is our chamfer. Okay. We will delete the chamfer. Okay. We'll take a look at the next one, and the next one is the shell. So shell is thin-walled. So if I click on shell, I can select the OK, and what will happen is that I will empty out the internals. However, it will still look as a solid object. If I select the surface, what that will allow me to do is then it will show me what the thin-walled vessel is. As always, I'm able to grab the little yellow arrow and drag to indicate the thickness itself. So I'm going to make this relatively thin. So I'm going to make this, say, 0.25 millimeters thin. And then I'm going to click OK. And then here we have our vessel. Okay. Shell is actually very versatile. If I edit the feature, and then I will give the thickness, the wall thickness, I will give it as 1 millimeter. However, the bottom, I would like to increase it by an additional millimeter to make it 2 millimeters. In order to do that, I'm going to click the double-headed chevron arrow right here. And then I'm going to select, in this case where it says unique face thicknesses, I'm going to click on click to add, and I'm going to select the bottom. On the bottom, I'm going to change the value from 1 to 2, and then I'm going to click OK. Now, to give it a better view, I'm going to simply put it into the front view. I'm going to go to the view panel, and then I'm going to change my visual style to wireframe, and that shows us that here the wall thickness is 1 millimeter. However, the floor thickness is actually twice the thickness. This gives us a good tool in order to adjust dependent on thicknesses for various surfaces. I will put this back into shaded. Okay. With shell, we also have quite a bit of power. So in this particular instance, I'm just going to simply remove these two fillets. I'm going to increase the thickness of this particular rectangle. I'll make it, say, 25. So there's 25. I'm going to take my fillet, and I'm going to do the following. I'm going to select all four corners to start with, and I'll just give it a fairly generous fillet size of, say, 11.5. I go apply. Then I'm going to select that edge, and I'm going to select this edge, and I'm going to make those 10. Click OK. So now we have this particular object. Okay. We're going to use shell. However, we're going to use shell in a unique way. We're going to click on shell. I am going to give it a thickness of 1 millimeter. And then if we take a look right here, it says automatic face chaining. So automatic face chaining means that if I try to select it, it's going to try to remove this, every single surface. I don't want that. I want to selectively remove certain surfaces. So I'm going to take the check mark off, and then I'm going to do the following. I'm going to select these corner surfaces and these corner surfaces. Okay. And then just I'll remove these surfaces. Actually, no. So if I hold down Control, I can put that surface back. So if I click OK, I get this coming through. The shelling tool is an extremely powerful tool that will be demonstrated in the coming lectures within class. One of the projects that we will be looking at will utilize the shell to create a very complex part. So to briefly recap, we've looked at holes, fillets, chamfers, and shells. This gives us a good indication of the kinds of tools that we do have in Inventor when it comes to place features. There are other tools within the modifying toolkit that we will be looking at in upcoming videos. However, with that, I'm going to leave you. Have a great day, and I will hope to see you in the next video.